In this particular task, we want to evaluate the efficacy of a weight loss medication. And what we frequently do in this case is we carry out a before and after experiment with a given set of individuals. So here we have 5 students, and we measure the weight for these students before and after the treatment, and we want to find out whether there is actually a reduction in the weight. So our null hypothesis would be that there is no reduction in the weight, so that the mean of the 2 samples, and in this case they are paired or dependent samples, that the mean would be 0. And so what we can use for this is a paired t-test, and we can very easily do that. So Excel has a pre-built function for t-tests. So all we need to do is we start typing equals t-test, and here we come up with this predefined function. So double click on that. It asks us for the first array, that is the first set of data, and with the left mouse button pressed, we just simply highlight that, comma, the second array, that is after the treatment, that is this one here. And now it asks us for the tails of the distribution. So remember, one-tailed means that we are pretty sure that one of the means is smaller or larger than the other one. Two-tailed means we are not sure whether there is really a difference. We just simply say they are different, but we don't commit ourselves to saying which one is larger and which one is smaller. So unless you have really good evidence that you should use a one-tailed test, I would always go for a two-tailed test. So in this case, we just simply enter 2 in this here. And the last parameter for this t-test is the type, and we have the option of 1, 2, or 3. So 1 indicates a paired or dependent samples, and that is exactly what we have here, because the samples depend on each other. They are related, for example, to this first student here. So we can easily say that it is a 1 type that we want here. So we get a p-value. So let me write this down. P-value equals 0.034. And we should have specified our null hypothesis earlier. So here is our null hypothesis, where we said the null hypothesis is that there is no difference between the weight before and after. And we said our significance level alpha is 5% or 0.05. And if our p-value is lower than alpha, we can reject our null hypothesis. And indeed, this is the case. Our p-value is 0.03, which is smaller than 0.05. So we can say there is definitely a difference between the weights before and after the treatment. So we also want to figure out whether this weight difference is in practice significant. And for that, we calculate the effect size, Cohen's d effect size. And in this case, what we do is we just calculate the mean of the differences, and this is where the Cohen's d for a 2-sample independent t-test differs slightly from the calculations for this paired t-test. And mean of the difference divided by the standard deviation of the differences. So how do we calculate that? Well, that's not terribly difficult. All we need to do here is we calculate the differences for each student. So this would be equals weight after minus the weight before. So this student lost 20 kilograms. And we do that for all 5. So there is some serious weight loss going on. And all we need to do is we want to calculate the mean of the difference. So we calculate the average. So here is the average. And again, with the left mouse button pressed, we get the average. What is the mean of what each student lost? So 31.1 kilograms. Obviously, this weight loss, the difference is in kilograms. So that is our mean of differences. And we can also calculate the standard deviation of the differences. So equals standard deviation of the difference. And since we are dealing with a sample, we need a standard deviation sample here. And again, we do exactly what we've done before. We just simply highlight the cells, close the bracket, and we have our standard deviation here. Now, I should have said that when we are dealing with Cohen's d, we are not terribly interested in the sign of it. We just simply calculate the absolute value. So here we have Cohen's d equals 31.8 divided by 22.58, and that gives us, let's just simply do this calculation, equals mean of the differences divided by the standard deviation of the differences, and that gives us, we are not too worried about the negative sign here. So that gives us a Cohen's d of 1.4. And from a previous table, we know that if the Cohen's d effect size is larger than, say, 1.2, we are dealing indeed with a huge effect. This effect is massive, and we can almost sort of from intuition say, if the students indeed on average lose almost 32 kilograms, then we believe that there is something really massive going on, and we have good evidence that the drug is not only statistically significant in its effect, but also leads to a very big effect. Now, obviously, we only calculate a Cohen's d effect size if indeed we reject our null hypothesis and there is a statistically significant effect visible.